Good afternoon, everyone. My name is Kunwar Singh, and I will be serving as your moderator today. We have lined up some interesting presentation and for you and this on this timely subject. But before we get started, I want your few minutes of your time. Each presentation will be 15 minutes long, and there will be 2 to 3 minutes question answer session. And if we run over time, we will have question answers at the end of the session. And you can find all the presenters at the end of the session if you have more questions to ask. Now, moving along to our session, please welcome Ahmad Mohassel, who will be speaking to us on identifying cropland abandonment using Earth observation. Ahmad is a senior data scientist at the American Institute for Research. He specializes in the intersection of data science and international development and uses Earth observation to tackle food security questions. Ahmad is currently working at DARPA World Modeler as a principal investigator. Thank you. And please.
Being here, I know it's going to be like a toughest session after lunch. A lot of you like traveled across the Atlantic. You might be jet lagged, so I hope have you spending here. So today I'm going to talk about an ongoing work that we are doing in collaboration with my colleague Eric Muchugu, who is in our Kenya office in Nairobi, and this is based on a project that we have with USAID, and we try to use Earth observation to answer some questions. I'll first give you a context and of what we are looking at, and the motivation for this kind of work. So the work today I'm going to talk about would be on Sudan, and the reason we are looking into this is that in light of the recent surge in conflict in Sudan that started April of this year. We've seen a lot more displacement, happening in the country. 4 million people have been displaced, and 42% of the population of the country are going through food insecurity phase between like July and September, which is, if you look at compare year to year, this is like double what we had last year. So like a quick comparison of like what we were looking last year compared to this year. These are from the the food security outcomes from Fusion and USAID. If you look, a lot of areas you see here like doing worse than last year. A lot of areas that were in kind of like a crisis mode last year now like moved to emergency. And if you look at that, like you see like that pattern across different regions. And now, what has to do, this kind of like situation has to do with agriculture. So now I'm pretty sure like a lot of you are familiar with the accurate data. As today and yesterday, a lot of researchers referred to this data. If we kind of look at the map of conflict in the country, you'll see that a lot of places that like experience surge in conflict, some of them in the east side in the Darfur area and Khartoum, and we correlate that, we basically overlay that with the NDVI, which, no presentation, observation agriculture, the presentation without NDVI. We're going to look at that, in those areas, comparing year to year, compare August of last year, this year, we'll see like a drop in, NDVI index. And to give you a, context of the country, so like when we're looking at the country, these areas, EU states here are the one that with more concentration of agricultural land. And if we go and maybe zoom in the Khartoum area, which is the area that most of the conflict is concentrated, and not only look at the overall NDVI, but also look at the change in the vegetation of cropland area. You'll see that comparing to the long-term mean, and also compared to the numbers from last year, over the first few months of this year, we'll see that, okay, like the trend we're looking at, it's aligned with the long-term trend and last year, but, after April, when the conflict surge started, we'll see like a significant drop and experiencing a drop in NDVI. And for the context, I included the data from rainfall to this is just like a illustration. Included rainfall to make sure that not necessarily been driven by worse than average rainfall. But if you want to the statistically significant numbers, we're gonna investigate more on this. But this is to give you a context, a piece of evidence that we are looking at. And now, so if we want to look at the impact of conflict and agricultural production, there could be a few channels that this could, the conflict impact the level of agricultural production. So first of all, the conflict broke in April, and as a result of that, there were limited time to prepare land for a new cropping season. And as a result of the conflict that been affecting the whole country, the markets are disrupted. There are less access to agricultural finances. Maybe for the context of Sudan, that might be less relevant, as we are dealing with a lot of smallholder farmers, and also access to input like seed and fertilizer would be happy. And also because it's a insecure environment, physical access to land would be restricted for the farmer to access. So we expect that will be another challenge. And as a result of displacement, a lot of labor would migrate, for a few years, don't return to the land, and we kind of expect that some of these impact would be in long term, but a lot of them we might experience. Some of the impact would be in short term, but a lot of them could affect the the crop production and cropland area in long term. So what we are trying to do here, we're trying to develop a model for identifying cropland abandonment using remote sensing data. We are focusing in the country of Sudan. We're going to use data, most recent data from 2020 to 2023. As we go further, we update the data. It would be interesting what we see in the trends, what kind of new pattern would emerge. And we're going to look at the impact of conflict on the cropland abandonment, and how that would eventually impact food security. And we aim to scale this model to the whole country. So it will be available. We could understand the scale of crop abandonment in the country, because a lot of those areas that experiencing conflict obviously would be really hard to get any underground data. So we're trying to, as I'll discuss further, we're trying to collect data from the areas that less affected by conflict, and when we have a model, we train the model, use it on the areas that are prone to conflict. And then at the end we use that output that the the knowledge from the cropland abandonment, knowing which lands, which croplands are being abandoned, and use it as a piece of information to calibrate our crop model that I'll discuss in a few details. So time. So just looking at the recent studies, a lot of studies that done recently on cropland abandonment, and a lot of them are in the wake of some most recent conflict, and looking at the years, a lot of this studies coming from the most recent years that we had the surge in the availability of data and the computational power. So there are studies in Ukraine, South Sudan, China, and we have a couple of studies in Mali. And I don't want to bore you with details, but a quick overview of the methodology we're going to use is that basically we have data from Sentinel-2 and Sentinel-1, and we want to go like a little bit, step further, look at the different, a couple of different index. So, for example, instead of solely looking at NDVI, we're gonna look at EVI2, Enhanced Vegetation Index, that would be able to like give a better identification of cropland versus grass. And the other index we're gonna look is regarding to soil, dry bare soil index. We're gonna look at that. So and each of these indexes, we are aiming to identify the difference between like different kinds of land. For example, like we want to like see like if we can like identify the difference between crop and grass, because when we're looking at only like, for example, NDVI, in some cases there might be like a land that's been abandoned, but like grass being grown in that land, and it would be hard to distinguish between crop and grass. So basically, like there's going to be like 3 index that we're looking at and using in our model, and then as I said, we're gonna map the crop field and use it into the gridded crop model simulation that gonna. So regarding the ground truth data, we are kind of in the process of talking to partners. It's I believe all of you agree that's the toughest part of the research, that collecting ground truth data, especially in the conflict affiliated area. But we had some success, and we were able to like look at some areas, but I expect that part of the process would be kind of slow and wouldn't be like straightforward. But one of the challenge that we face is that we the data that we're gonna collect, because like a lot of agriculture areas, going back to the map, are not affected as much as the other areas with the conflict. So we're gonna focus on those, but obviously we need to be careful, like the way we collect data. We wouldn't have sample bias, versus land that been abandoned versus the one that is still in use. So, and then I mentioned that our work on using crop modeling. Basically, the kind of like the motivational light bulb moment that we started this research was that we had like a crop modeling, which basically like we based on the DSAT model. If you're familiar with that model, we are doing like a simulation to look at level of crop production in different area, but after this conflict broke out, we realized that, okay, like we need some calibration to the model. So like to capture, exactly what areas are being planted and being used as crop. So, and just a quick overview, basically, like, crop model, we have used different types of variables, weather, soil, or crop management practices as input. We do like, simulation, and at the end, we simulate the yields for different types of crop. And that's what's is interested to our clients and partners, that like, they want to see like where the crop production is lower, so they would be able to like, target demand and yields. And last but not least, the lack of systematic data collection in areas impacted by conflict underscores the importance of leveraging remote sensing and Earth observation to look at the agricultural output. Doing this work has its own challenges. The challenge is that collecting data, we are looking at the conflict impacted environment, and has its own challenges that need to be resolved. And the next steps for this work would be to just collect more ground truth data, model, and then like when we have like a reliable model, we could expand, scale it to a national.
Thank you. My name is Tina Moyo from the Namibia University of Science and Technology. Thank you very much for your insightful presentation. My question is simple. I know this is a crop model. It's a crop model that you presented here, but my question is, how, or is there any possibility of the model integrating livestock production? Yeah, maybe let me just leave it at that. Livestock production.
Livestock production into crop model?
Is there any possibility for the model to integrate livestock production in view of food security, being both crops and livestock and not just crops?
Yeah, that's a really good question. We haven't thought about like looking at the livestock in the event of conflict, but previously we look at we did the livestock model to basically we were trying to use NDVI, vegetation index, to see like how the stuff like livestock would impact NDVI, basically like controlling for like different corresponding variable, and then see like
Thank you very much. I'm Ajit from India, and happy to know that you are using crop simulation model for different purposes. Our group is also involved in similar kind of research, and especially there are certain issues when you are using crop simulation model with the geospatial technologies. Like the one issue would be how you are integrating geospatial technology into crop simulation model. That is very, very important. There are different techniques like forcing techniques, reinitialization of the technique, recalibrations technique. I am not sure as to what techniques you are applying into your study, number one. Number two is when you are using crop simulation model, so that the real challenge will come from the data, because the DSET which you mentioned is data extensive model. So my question would be as to how you are dealing with this intensive data set which is required by DSET simulation model. Thank you.
That's really a question. I first of all acknowledge that our expert on the sub model and crop modeling is Eric, my colleague in this work. So you probably have like better answer to your question, but I try to answer the question to the best of my knowledge. Yeah, I acknowledge that like it's very intensive, and like even like when we are just running the model on like a small area, it takes a lot of time, and you know what we're trying to do here based on the pre-existing model that we have for the country, we want to like, because you know when you're using the set model, like, assumption planted in that different areas, we want to like use the output of the result of this cropland abandonment model to maybe like have a bit better calibration of the model. So details, it's the part that my colleagues dealing with. So I'll be happy to discuss that.
Thank you very much. Hello, everybody. So maybe a couple of disclaimers before I start this presentation. So a great researcher told me last week, nobody really care about graph, and you should start to just convey messages another way. So I actually disagree with this statement, but I say, okay, like let's try this. And based on the level of discussion that I've seen today, I think I was pretty much wrong to try this with this audience. But my goal here is just to convey a few like very simple messages from this study that we conducted in Senegal. Maybe the second disclaimer is that it's not exactly an impact evaluation, and it's more like the stages that come before we actually reach the stage to being in a spot to do an impact evaluation. It's more an exercise that we were targeting to make a proof of concept and have like an exchanges with the operational team to see like how this data could inform their decision making. So very briefly about the project being studied. So this is a large irrigated perimeter in the north of Senegal. So this is about 2,000 hectares that you can see on this map, that are divided into roughly 2,000 plots. So it's about like 1 hectare per plot. And so this irrigated perimeter was operated by the National Irrigation Society of Senegal, working along the Senegal River. And so these plots were allocated at the beginning of the project to some small to medium scale farmers. So the average field size I mentioned is 1 hectare. And so before like making the statement or like the proof of concept that I'm trying to expose to you, I'm going to present you the data that we had access to, and that was actually collected by the implementing agency. So this is important. So the reason why we choose this project is not because this is a particularly emblematic project to evaluate. It's because we had access to a level of data that we almost never have access to in AFG projects. So you can see again like the map of all the irrigated perimeter. And so the first thing that you see is that all the plots are actually delineated. So that's not something that was done with Earth observation. Like the implementer of the project, for some basically for some cadastral reasons, maps all the plots, or maps all the irrigated perimeter and all the plots within it, with some basic information on the size, the people being attributed the land, and so on. The second level of data that is much more rare to get are crop cuts. And for those of you who know crop cuts, this is for people doing remote sensing. It's sort of the holy grail of the data that we are looking for. And so basically, again, this implementing agency, what they've done is that they every year, and so for every season, so twice a year, they go in the field, choose a random selection of plots, and do like a small harvest, basically, that they dry and weigh to have some estimation of the yields at the plot and at the perimeter scale. So we had all this data that was in theory very much very precisely geolocated, and that was telling us some basically some exact yield estimates, which again the literature is supposed to be much more accurate than self-reported yields from farmers. And so this field data we combine with some satellite-2, Sentinel-2 mainly imagery, and a bit of Sentinel-1 to see what we could say about first land use and then maybe about yields. So here is the statement. Let's see what we can do when we have this like very rare and suppose extensive and accurate data. Where can we go in the statements from? Let's just look at cultivated plots. So let's try to map the perimeter and see for every year and for every season whether the plot is cultivated or not. Supposedly not too difficult. Then second stage is let's look at the NDVI. So I allow myself to use the acronym because you've heard this over 1,000 times, so I don't need to detail what this is. And let's look at just this NDVI. We ignore for the sake of the exercise all this crop cut data that we have, and let's see whether we have some good correlation between this NDVI and yield. And then the third stage is to use all this biophysical data to calibrate the satellite imagery to try to actually have accurate estimate of yields with this model. So let's start with the first one, in theory, the simple one, identify cultivated plots. And so this is basically the map that we get for 2017, where you have four classes of, you have four possible classes. Either the land is not cultivated at either season, so that's the brown. You can see like a large area in the west. You have either cultivated during the dry season, meaning that the irrigation system is actually being used, only used in the rainy season, or used in both, which is like the darkest blue color. And so we conducted some accuracy assessments, and we find that based on all the field data that we have, we get above 95% accuracy to detect the exact category. Basically, like mapping the NDVI signal throughout the year to identify in which class the land is. And so this is the first result, and we can see year after year the evolution of the on the land. The good news is that if I'll do it again. I don't have like those fancy things, but you can see that it becomes darker and darker, meaning that slowly and slowly the farmers are more and more adopting either the double cropping, either cultivation during the dry season, which is easier in Senegal than in the rainy season if you have access to irrigation. So first, interesting and good results. And maybe also an interesting result here is that for us, this was really the tool for discussion. What I'll discuss after and trying to estimate yields is much more experimental and again, like trying to make a proof of concept and see up to where we go. This is to us the real interesting finding, like to discuss with operational, to discuss with also with AFD teams who are less contact to the field and see like the trends in cultivation. So first of all, like the good results of more and more land being used, but also some other things that you cannot really see on the picture, but that we can, with some more analysis, find about some places that are less cultivated during the dry season because of some salinity issues or some pest invasions and so on. And this is the kind of things that we can discuss based on this map. So I strongly believe about the power of just having these maps on the table to have concrete operational discussions. So let's try to be more experimental now and see just with this vegetation index, can we say something about yields? And so here is the result. So this is, I think this is just the rainy season that you can see here. And so whenever it's gray, means that the land was not cultivated this year. So we did not we removed this from the analysis, and you can see like all the cultivated plots, the level of greenness basically that the satellite is capturing. What's very interesting here is that, first of all, if you dig in the literature and you just take this and assume, the literature is going to tell you that the vegetation index is strongly correlated with vegetation biomass. And biomass for rice, at least, is supposedly very much correlated to yields. So in theory, we could take this and say, so the greener the field, the more yields we have. Then when we put these maps on the table and discuss with the implementers, what we realize is that 2020, and you can easily see that, 2020 is the greenest on the map. And 2020 was actually a disaster of a year for rice yields in northern Senegal and in this perimeter in particular, because of several reasons. Also salinity of water, some pests, but more importantly, probably also from some invasive species called the tika, who have like fully invaded these lands. And so we don't have evidence of this, but we can easily suppose that what we are seeing here is actually not a decent part of this is actually not rice, but some other species that you absolutely do not want to see on your fields. So I take this moment for maybe like a second, I think, important insight for us, which is the importance of qualitative data also, I think we've little discussed today, but that is very much important here, because this is only based on these interviews and these discussions with people that actually know the field, know what happened over the perimeter and in specific areas to understand what we are actually seeing. So this is an important lesson for all of us. So it's basically a no-go for at least for northern Senegal to use this NDVI as a proxy for rice yields. And now we take back our crop cut data and use this to calibrate our model. So using NDVI, but also some other proxies to see whether we can get some accurate estimations of yields. So these are the results on the left-hand side for the dry season, on the right-hand side for the rainy season. So this matches to the qualitative data that we have. The yields are much better in the dry season because the environment is much more controllable than it is in the rainy season. So at least the order of magnitude seems to be right. What we find basically is that if we have all this data for a certain year and we apply this model to this specific year, which means that we need to have continuously this data and to be able to, to collect this data every year and to rerun the model every year, then we get something nice, which is we have a lower uncertainty that we can see here, which is basically in the order of half a ton per hectare. So for example, for the dry season, this would represent this would- right, which is fairly decent to have, considering like how difficult we know it is to estimate yields. Now, if we want to have this data and apply it to another year, then it's more like the uncertainty that we can see here. And so if, for example, if we take all the data and we apply this to 2017, so we're still using 2017 data, but we're also using more, then we find over 2 tons per hectare in uncertainty, which is basically like over 30% uncertainty in our data. Conclusion, with all these data, in this case, we can make some claims about yields if we have this data all the time and being able to run these models. We still have to use this with caution. So basically, my conclusion of all this, that I've already said continuously, but we see like this is a powerful tool. Obviously, it needs to be always complemented with field data. I think we've all reached this conclusion so far today. It remains very rare to have both the extensive and accurate, at least in AFD project, to have this kind of data and not to collect this data on the researcher budget, because we rarely have this kind of budget. So being able in the project and from the implementer to have this kind of data is extremely rare, and basically this is our main study, being able to do this. And even in this case, I think we can say that it's very hard at the moment to go to the level of yields. However, we can say some very interesting things about land use and have an interesting tool for discussion. Thank you.
It's very interesting. Thank you very much. Very, very practical. And, like the conclusion, there was some observation that was here, and I don't know whether you have been able to, or the program people have been able to discuss it. When you look at the 4-year, averages that you gave, both the early and the late, you see that 2019, both the late and the early were higher than the other 4 years. Is there any observation? Is there any discussion that you had with them? Because I will not call it outlier, but it's almost, above average, when you look at the other one. What was going on at that time? Is it fertilizer, free fertilizer? Is it, production, because you see that, and it's a good discussion, especially in your conclusion, when you were talking about using both qualitative and quantitative data. This thing brings a lot of discussion to see what was actually happening, so that, the best practices can be learned and be used.
Yeah, thank you. Basically, 2019 is the year where there was the least problems. So it's the year where the mechanization was in the fields on time, where the pest was not too destroying, where the salinity of water was still manageable. I think that basically, so people started farming this perimeter in 2017. 2019, I think, is the peak where they realize that it's hard to farm in the rainy season, and I think that's part of the reason why you have less of this in 2020. It's also the year, I think, where the weather conditions were the most suitable to farm in the rainy season. So I don't think that you can see less people in 2019 that farm in the dry season that you can see in 2020. However, you do see a reduction of farming in the for the reasons that I mentioned.
Yeah, thanks, Pierre-Yves. I'm Pierre-Yves Durand from Microset in Senegal, also working with Manobi Africa, a private company. I want just to say two things. One is early and late rice. I think I would advise to change the denomination because those are actually two distinct seasons. And when you say early or late, it's related to early or late planting within a season. And one element of answer to my neighbor is that the second season is dependent upon performance in the first one. So if farmers plant early in the first cycle, they will harvest early, and therefore they will be in a position to also plant early in the second cycle if they do so. And early plantings are associated with higher yields. So a higher yield in the first season tends to be associated with a higher yield in the second. And a general comment I want to make, and I can discuss it with you separately, is that I see a lot of opportunity in remote sensing for monitoring farmer compliance with good agronomic practices. And that points to what you mentioned by qualitative data, which is not necessarily qualitative, but has to do with monitoring management as opposed to monitoring the outcome on the crop yield. In industry, for example, as I understand, people are far more interested in compliance with management practices than in the final yield outcome, because the yield outcome, if they know the management, they can derive it with high confidence. Yes, and two other quick things is the yield penalty you observed, I think, in 2020 was not only the consequence of the bug infestation that only became apparent when people weighted the rice on the scale, because the grain appeared perfectly good, but half of the starch had been sucked out. But also the COVID, because in 2020, Senegal implemented a lockdown, and all the temporary labor that migrates from central Senegal to the Senegal River Valley was not available to harvest. So you had a big drop in harvest levels because people had no resources to access mechanized equipment because of funding issues, but also to access manual labor. So there are many factors, I think, that argue in favor of using more earth observation to monitor farmer compliance with good agronomic practice. And also banks, I could show you a curve where we show on Sentinel-2 data in that same area, the effect of a promise of credit followed by the credit not coming and reflected in an increasing flooding rate, stalling, and then when the credit came, the flooding rate again increases. So it's a very interesting ecosystem to study. Thanks.
Thank you, Dr. Kunwar. Very good afternoon to all of you. I am really very happy to be here to meet you all and collaborate. Yeah, our post-lunch session is very tough. Hope I won't make you feel sleepy. So the topic I'm going to talk is developing climate smart rice hybrids for global food security. I am from India. You all know rice is the key food crop for global food security. More than half of the world population is depending on rice, and it is cultivated in more than 100 countries. Then with an area of 165 million hectares, with the production of 520.9 million tons on milled rice basis. So 90% of the global rice production is coming from Asia. China and India is the major contributors. Coming to Indian status, we have 43 million hectare area in rice, and we produce 130 million tons. Then, and also we export. We export almost 22 million tons to different countries. Coming to the past 2 decades, the area production productivity trend, if you see in India, the area is decreasing. Previously, it used to be 45 million hectares. Now it is 43. Then production level is means increasing trend, and the yield is also, productivity also increasing. Yeah, due to high yielding varieties and hybrids released by different centers. To the export condition, I said like we do export rice, especially basmati and also non-basmati. After COVID, our export level had gone up. Then we earn a lot of foreign exchange by that, like around 10 billion US dollar. Then recently, last month, like last July, Indian government banned export of rice. Then because of that, global rice price had gone very high. It is around $700 per, like it had increased very high price. So India's rice production plays a very important role in global food security also. Coming to Indian status, like we have a huge target. We need to produce by 2050 at least 168 million tons. As of now, we have 130 million tons. Due to urbanization, we can't extend the rice area by this, but at the same time, we have to increase, means we have to produce more rice from the same. In this, hybrid rice is one of the key technology. It can produce more rice, like 10 to 15, 20% more rice can be produced by cultivating hybrid rice. Then if you take China, they have only 30 million hectares, but they produce 150 million tons of rice. That is only because adapting hybrid rice. They cultivate hybrid rice more than 50% of the area. So, so the success of this technology is very well demonstrated by China. By like in India, by seeing China's success, we also started hybrid rice program in the year 1989 with the support of FAO and other organizations. Then so far we have released 137 rice hybrids. Then mostly private sector is playing very important role in hybrid rice research and technology. Then they have 95 hybrids they have released. The area is only 3.5 million hectares in India. It is 7% of the total rice area. But the area is not expanding from it is stagnant like 3.5 from 2020. So that's the reason we need really a lot of interventions to increase the area. Apart from India, out like no, China is the one who like they cultivate almost 50% hybrid rice. Then outside China, we have a lot of scope to enhance, like increase the hybrid rice cultivation area. If you take like India, we can see in this, like if we can really map the area suitable for hybrid rice and all, we have a lot of scope outside China also. Then rice is one beautiful crop. It can grow in different ecosystems, starting from irrigated, upland, hills, then saline soils, acidic soils, and below sea level, then rain-fed lowland, deep water. So we have like kind of rice can grow in different ecosystem, but only with the point that productivity will be very less. So that we need to address. apart from like different challenges we face because of climate change, first, like not only climate change, we have many challenges ahead of us, like rapid urbanizations. We don't have, we can't expand the cultivation area, then flood, drought, then that high temperatures, then these are all really we need to address. Then water is very important resource again. Rice is a water loving crop. So we can't, but we are not in a position to give more water. That's the reason we are shifting from irrigated rice to dry, DSR, direct sown rice. And cost of cultivation is day by day, it is increasing. Then poor soil health. Next is changing pest and disease pattern. It is keep on changing. Then the knowledge, it is not reaching to farmers. It is very slow. Though we develop many varieties and hybrids, but to reach farmers, it takes a lot of time. These are all the things we need to really address. Coming to our main interest, like how we can use satellite imagery data. We have a lot of challenges in hybridized. As I said, it is not, area is not expanding. We have different reasons for that. But the main reason is like hybridized seed production. If you take, India is a vast country, but we produce hybridized only in one state, that is Telangana. Like most of the private companies are located there. Seed production is happening only in that particular region. This is maybe because we don't have proper map, like where are the locations we can really do hybrid seed production. As of now, we don't have. Then we need some of the weather factors. We need to map it. Like this is outcrossing rate is depending on temperature, relative humidity, light intensity, wind velocity. These are all the factors we have to keep in consideration. Then ideal situation would be our relative humidity 50 to 60%. Then maximum minimum temperature is 28 to 30 and minimum temperature is 21 to 22. Wind velocity should be 2.5 meters per second. This is ideal for hybridized seed production. In China, they have reported 24 to 28 degree. Then relative humidity is 70 to 80%. With diurnal temperature change can go up to 8 to 10 degree with sunny days. So this is some study they have conducted from IRRI. They have mapped like in India, hybrid seed production area, they have using 8 years of weather data, historical weather data they have taken, and they tried to map, but it is in a very small level, like small study. It is not a very extensive study, and they haven't used any satellite imagery data and all. I think we have a scope, we can do it. Then in same way, Philippines also, they have identified some of the areas suitable for hybrid seed production and two-line seed multiplication based on the temperature. Then some of the interesting other areas we can really, well, actually, I would like to you can think in this direction. Though I am not directly using all this data, but we wanted, if you can help it out, it would be really great. We can achieve many things, like assessing flood and drought affected areas using rice satellite data and classifying rice ecology based on its suitability for rice cultivation and especially yield. So my previous speaker, he really gave some idea how we can map yield. Then hybridized seed production area mapping. Then area suitable for DSR cultivation, like to save the water. So the here idea is, if we can map flood and drought prone areas and vulnerable areas, yield loss, we can map it. Based on these results, we can recommend to farmers not to grow hybridized in that particular areas, because hybrid seed cost is very high. So they should not end up in severe loss. So we can advise them not to grow hybrid crops in those particular areas. So that is the idea. So maybe this is like my thinking as a breeder. I was like trying to figure it out, like how we can help farmers. Please have a thinking in this direction. Then coming to the methodology, whatever like I could go through some of the literatures, and some of my colleagues I could discuss with the agronomist, and we could map, figure out this methodology. I think you all are experts, so I think no need to explain so much. So Sentinel-1 data can be used. It has accuracy of 10 meter. We can images can be processed at 10 meter levels, but only we have a kind of how to cloud cover, how to overcome the cloud cover. I was thinking in my this one, because most of the wet season, half of the days, rainy season, cloud cover would be there. So how we will be able to really identify that? Maybe you all should guide us. Then coming to our institute, actually we have, I just want to tell you that we mainly concentrate on irrigated rice. Then we have different centers working under us, 45 under centers, cooperators. So if we have to plan some study, we can do it in a very better way. We have 45 funded centers under us. Then we collaborate with international institutes and also international organization FAO. So I just want to tell you all, this is with respect to my institute. Then I really thank ICAR for nominating me to participate in this, and thanks to GeoField, BMGF, and FAO so for their sponsor. Then so my collaborators, friends, family, thank you one and all. Thank you. So thank you.
Thank you, Revathi, for making nice insight into what the rice ecosystem is there into our country. First is a question that I would like to ask. When you are producing this hybrid rice, whether that is two-line hybrid or three-line hybrid, that is the question number one.
Okay.
And the second is suggestion, because you have launched, this to the audience as to how we can overcome this cloud issue. So you had mentioned in your slide that the Sentinel-1 is basically the synthetic aperture radar, and it is having really the capability of penetrating through the cloud cover. Okay. So even there is no very thick cloud cover, it will provide you the image. But then there are certain inherent issues using SAR data, because you will have only a few channels available. But you can also make use of the different polymetry that is available. But my suggestion would be, when you are applying geospatial technology, you should apply it in the combinations like SAR and multispectral remote sensing together. You can use for making any assessment or anything. So
I think you have to be helping in this direction if we plan. For your first question, we use three-line hybrids. Like in India, two-line hybrids now recently only 2 hybrids they have been released. They are trying to develop some more hybrids. But as of now, whatever hybrids we have, it's like three-line hybrids.
So then there would be a suggestion from my side that mine institute has already developed 2-line hybrid.
Okay.
So you can also collaborate with our breeders.
Yes, I know you're from Pantnagar. Right. Thank you. Anything else? Whether all of you understood or different area. Some question in chat box. So much.
Could you get your mic, Kunwar? Turn your microphone on for the virtual. Thank you.
He will talk about, do large-scale agriculture investment exacerbate environment degradation? Solomon is a director of research at the International Center for Evaluation and Development. His current research focuses on the impact of refugees on host communities, large agricultural development on the local communities, physical infrastructure on nutrition, diet, gender empowerment and equality, and cost benefit analysis for horticulture productions. Welcome, Solomon.
Thank you, Kunwar. Let me share my screen. Give me a minute. Can you see my screen, please?
No. See you, but not your presentation.
Okay, can you see it now?
Yes, we can see it, Salam. Thank you.
Okay, yeah, thank you very much. It's really great to be here. I was supposed to be in Rome and in this session in person, but due to visa issues, I couldn't make it. I really apologize for this, but even if I am in person, or I would talk about, as Kunwar mentioned on the title called "Do Large-Scale Agricultural Investments Exacerbate Environmental Degradation?" And this is a joint work with Workana Hasmara Kase from University of Condor and the Southwestern University of Finance and Economics back in China. Yeah, so the main motivation for this project or for this paper is that the adoption of large-scale land investment as a major policy tool in developing countries to ensure food security and also to increase, agricultural productivity in those countries, especially in Sub-Saharan Africa and Southeast Asian countries. And this happened since 2008, but from 2008 and onwards, the land transfer program or the large-scale land investment program intensified because of the food price rise during that year and the so-called, the land rush to the African and Southeast Asian countries to feed, the population in their respective countries. According to the land matrix data back in 2020, and this number should have changed by now, about 100 million hectares of land changed hands from, local communities to domestic and international investors. This is a huge policy shock in the developing world, and this inevitably has a large scale effect on the social, economic, political, and also, environmental outcomes. So we need to understand what impacts these large scale land investments have on the different outcomes, that's happening in developing countries. I would say the literature has responded somehow to this call of, assessing the impact of large scale land investments. But most of the literature or most of the studies focus on human rights violating, local communities participating in the implementation process of, the policy. And they find mainly that there has been a lot of human rights violation. People are forced to leave their land without, enough compensation. And in the process of, the implementation process, local communities have been rarely consulted in the planning and implementation of these land investment programs. There are some studies also on the welfare effects of, a large-scale land investment. These studies come from Cambodia, Ethiopia, Mozambique, Sierra Leone, and Liberia as well. These studies mainly found mixed effects, but according to a recent meta-analysis we did on the impact of large-scale land investments on welfare and livelihood outcomes, that the effect is highly heterogeneous across countries and highly mixed also, but there is a small positive effect on the livelihood and welfare impacts of large-scale land investments in these countries, mainly in Sub-Saharan Africa and in Southeast Asia. And there has been also some studies who looked at, the mechanisms through which large-scale land investments could influence welfare and livelihood effects, and they also find, mixed findings along this line. There has been also one study on the livelihood strategy choice of, choice of local communities when they exposed to large-scale land investments or concessions, and the findings from this study is that it really, affects the livelihood strategy choice of the households. They mainly move from, agricultural communities to wage employment communities. So there is a structural change in the household economy when they exposed to large-scale land investments. The other dimension is that on the environmental outcome, there are a very few handful of studies on this, and these studies are found, negative impacts on large-scale land investment. So there is a call to rigorously assess, the impact of large-scale land investments on environmental outcomes, because these studies have been criticized onto basis. Some of the studies, they just take, a sample of land investments and try to draw conclusions from that. Some others, they use just approaches like matching approaches, propensity score matching approaches to do their impact evaluation. So there has been a call for a more rigorous impact evaluation in the impact of large scale land investments on environmental outcomes. And this paper is somehow a response to this call. So our objective is that they identify the impact of large scale land investments on environmental degradation, paying attention to deforestation outcome. And to address this objective, we ask and answer two questions. The first question is, what is the impact of large-scale land investments, large-scale land transfers or transactions on environmental degradation or on deforestation? Then once we address this question, we ask another question, whether the observed impacts occur on beyond the land is contracted, or is it occurring on the land is contracted only the environmental degradation impact. Yeah, so to give you a context, we take a case study of one region in Ethiopia, and to give you a context how the large-scale land transaction has been happening in Ethiopia. The large-scale land transaction program has been adopted as a major policy in the different strategic poverty reduction strategic papers in Ethiopia, but it has been intensified since the third poverty reduction strategic plan from the 2010 to 2015, 2016. And in response to this policy, the Ethiopian government made some huge progress to attract large-scale land investors, especially from foreign from abroad. In 2013, Ethiopia Agricultural Investment Land Administration Agency was established. The sole responsibility of this agency was to take care of the large-scale land investment program. And the Ethiopian government also introduced attractive packages for foreign investors in the form of tax breaks that could last up to 5 years, and also it provides loans up to 70% of the investment fund. Then what the government did is that to facilitate the implementation of the program, the government selected investment potential areas. According to some estimates, the government earmarked about 11.2 million hectares of land across the country and put it in the country's agricultural land investment bank. And the government started, transferring land from this land bank to foreign and domestic investors as well. So according to Taklamariam 2015, from 2005 to 2015, about 2.47 million hectares of land transferred to investors. Finally, the program was suspended in 2016, but it continued in 2018, but not as in a significant amount as it has been from 2011 to 2015. So as I mentioned earlier, we'll focus on the one region in Western Ethiopia called Gambela. And this is the area of, included, the area included in the land bank. And this is the amount of land transferred in that region. You see, it's, a huge amount of land has been transferred from local communities to investors, both foreign and domestic. So the two graphics show that the number of investment projects and also the area of land contracted in hectares from the beginning of the program until 2020. And as you can see that in 2014 and in 2015, the number of investments were really, really high. But when it comes to the area of land, we see peaks in two periods. The first one is in the area of 2011 and 2010, but the other area is in 2014 and 2015, just before the suspension of the program in 2016. So we will assess the impact of this program and this investment in that region on environmental degradation, paying attention to deforestation. Yeah, so the data we have is that we have three types of data. The first one is on the data on the large scale land investment. We got two types of data set on this. One is the list of large scale land transfers from the Regional Bureau of Agriculture. This data has the year, main variables are the year when the land was contracted, the size of the land transferred, and also the location until the Kabale level, zone level, and also district level. We have another set of data sets which shows the shape file, which is the shape file of large scale land transfers, which shows the polygon of each investor. But this data doesn't have a year, unfortunately. It has a Kabale, zone, and others. We try to merge this data set with the Kabale list to extract the year information from the list of LS and LPS data from the Bureau of Agriculture, but it has a lot of missing information. So we couldn't use the information more than the location of the investment. So the second data set we use is that the deforestation data set, that is the global forest change, or the Hansen data set. This is a data set with an indicator of deforestation, whether that pixel, the 30 by 30 meters pixel, is converted to deforestation from other land uses. The data has a temporal coverage from 2000 to 2022. So we used the entire data set for our analysis. So we also use other spatial and gridded raster data sets from different sources on population density, nightlife luminosity, river, road density, and all these things to use them as a covariate in our analysis. Equipped with this data set, so we used, as you see from these two figures, that our data, the intervention, the program was implemented in staggered manner. So we can't use the standard DID approach. So what we used is that one model, a version of the standard DID model called the two-way fixed effects, which helps us to control the year fixed effect and also the year fixed effect and also the GID fixed effect. I need to mention here that we are not using the pixels as a unit of analysis. For efficiency of the analysis, we created a grid, 1 kilometer by 1 kilometer grid, to speed up our analysis, because when you use the pixel, the 30 meter by 30 meter, it was taking really a long time. So our unit of analysis is that a grid instead of the pixel, the 30 by 30 pixels. So this two-way fixed effects model helps us to assess the impact of the investment not over time, by aggregating the impact over time. And our interest variable is that TIT, which is the post-treatment variable, and our interest is beta. The estimate is the beta. We extend this model because the two-way fixed effect doesn't tell us, in which year the impact was higher, in which year the impact was lower. We use an event study approach. We show the impact of the land investment program before it happened, some years before it happened, and some years after it happened. So we extended the basic model that the two-way fixed effects to help us to see effects, over time, before and after the program. We extend the two approaches also by controlling for, the covariates I mentioned earlier. So this is the result from the two-way fixed effects model. And for the whole sample, when you use the whole sample, the whole sample is that we see a significant and robust effects of large-scale land investments on deforestation. So deforestation increases. Large-scale land investment increases deforestation in the region. So this is robust when we control for year fixed effect, when we control for year and GID fixed effect, when we control for the covariates, but the magnitude of the effect goes down. The other one is we restricted areas to the land bank because we were interested to see if these areas were really different, were really similar in terms of their characteristics, right? Compared to the whole area, because the government selected these areas as a potential agricultural area based on different characteristics. So we believe that these areas are similar. So we restrict our sample to the land bank area or the potential investment area, but we see the same, a similar effect, significant and robust effect. But if you see for the fully specified model, we see a higher impact in the land investment sample, in the potential land investment, potential agricultural land investment area than for the whole sample. But the results are robust and the results were also significant. From the event studies approach, we see, sometimes after the event happened and also sometimes before the event happened. So what we see here is that 2 years before the event, there was a huge deforestation outcome. We see this as an anticipation effect. The local communities maybe anticipate that the land will be taken away and this extracted the forest over there. But this one we are trying to understand, the qualitatively if that is really the case. The second thing is that we see an effect 2 and 3 years after the investment. This is the investment effect, meaning that in the first year, maybe, and in the year the land was transacted, they might not start clearing the land, right? Because there is a process of, getting the license. They get the land, they get the license. Then if they need a loan from, the 70%, loan from the government, they need to go through, a long process. So most of the investment, they don't start clearing the land before they get that loan from the investment land. So it doesn't happen right away, but it happens, 2-3 years after that. And we see also, 8 years or after, we are trying to explore what happens, in the eight years. That's what the event studies approach shows us. When we restrict the sample, we see a similar pattern. Anticipation effect in the 2 years before the event, large scale land investment. We see also, after the investment, right after the investment in the area. So we were interested. That was the first question. The second question is: does the deforestation happen only on the land transacted or beyond that? So what we did is that we restricted our sample to areas outside of land investment avenues, grids outside of the land investment avenues. As we see it here, we see a significant impact for the 2 specifications, but not any impact on the other 2 specifications. So we rely on the fully specified outcome, specified model. This means that we don't see an impact of large-scale land investments on the areas outside of land transacted when we consider the whole sample. But when we restricted to potential areas, and outside the investment grids, the potential investment areas or the land bank areas, we see a significant effect all the way through, also in the fully specified, and also our main model. That one is when we include the grid fixed effect, the year fixed effect, and also include the covariates, we see an impact. So it depends in the area where we consider our analysis. If we restrict our sample to the potential land investment area, we see an impact. But if we see the whole sample, we don't see really. We see a non-robust significant effect when you consider the whole sample. The same we did also for this one, an event study approach. We see a similar effect as we saw previously, an anticipation effect minus 2 periods before the event, and we see an effect after the event. The same impact again when we restrict this to the potential investment area, and anticipation effect, and also an investment effect after a year from the event happened. So to conclude, we asked at the beginning 2 questions, right? So the first is, what is the impact of large-scale land investments or transactions on environmental degradation? So there is a positive effect on environmental degradation or on deforestation. The large-scale land transactions induced deforestation. This confirmed observed effects in other studies. The handful of studies I mentioned, they also find a negative effect on the environment. So we see a similar effect, that it induces environmental degradation. But most of the effects occurred not all the round. They occurred 2 years before or preceding years because of anticipation effect. 2 years after, because of the ideal operation start period. So we don't see the impact all the way through in the entire period of the investment. We see it just before and also just after because of the investment, the ideal operation start period of the investment. The second question we asked was, does the observed impact occur beyond the land contracted? We find mixed evidence on this one, depending on which sample we use. So the evidence is mixed on this. It happens, we see a significant effect in areas that were chosen as a potential agricultural investment area, but we don't see that in some other places. So the next step is that
Solomon,
we are yes, just 30 seconds.
Thank you.
Yeah. We use alternative data sets to see the robustness of our results. We use also alternative specifications by using different models, and we try also different falsification tests, to show that if our result is valid when we try different kinds of specifications of our treatment and control groups. So we will also further explore, the context by qualitative approaches. Thank you very much. Let me stop here and take any questions.
Because of time issue, we will invite our final presenter. Our final presenter is Valerien Pede. Please welcome Valerien. He will be speaking to us about evaluating the impact of stress-tolerant rice varieties through remote sensing and econometric methods. Val is a senior agricultural economist at the International Rice Research Institute and currently head of the Transformative Policies and Investment Unit. His research area includes applied spatial econometrics and regional analysis, impact evaluation of agricultural technologies and policies, climate change, food security, and poverty issues. Welcome, Valerien.
Okay, so with this many rivers, when the situation of flood, it caused a lot of damage to agriculture, in particular to rice production. So as you can see here on this map, the animation shows how, the flooding starts with the rivers from, the coastal areas to inland, and you can see how this has been progressing thanks to the remote sensing expert from the University of Arizona for developing this map. You can also see on the graph on the left here, the loss due to flood in Bangladesh full time. You can see, for example, in 2017, where the flood situation was very alarming, the loss has gone up to close to 1,000 tons of rice loss. So to cope with the damage created by flooding situation and other stress, the International Rice Research Institute and many other organizations have been developing stress-tolerant varieties. And you know that stress can come from many other situations. So we have biotic stress that could be from pests, genetic diseases, insects, and so on. But we also have the abiotic one to deal related to droughts, flood, and salinity. And I'm going to be talking to you today about flood. So anytime when I mention stress-tolerant variety or STRV, I'm just relating to submergence tolerant rice variety, flood. So you can see here on the map here, this is here in on our experimental field at IRRI. Those varieties, sub-1, who are able to survive even after 17 days of submergence, they still survive and grow. While the one that are not resistant to flood, they all die. You can see that there are many of them here. So many of those submergence tolerant varieties can survive more than 2 weeks into the water and continue to grow. And which is a great thing, because when we have situation of flood with the monsoon or with the typhoon in the Philippines and many other places, some of those varieties cannot grow. So we focus on Bangladesh and we look at many of the submergence tolerant varieties that have been disseminated there to do this study. So basically, what is the main research question here? We wanted to look at the impact of the adoption of those stress-tolerant rice varieties on yield and also on household welfare. The good thing here, we'll be able to tell you what we have seen so far for those who adopted those varieties and those who did not adopt, how were they impacted yield-wise, and also on other outcomes. One interesting thing here, which we proposed in order to get the funding from SPIA, was the combination of econometric approach with remote sensing. Yeah, there have been many studies on the impact of stress-tolerant varieties, and I know some of the people in the room here have done some RCTs. Some of them have used other techniques, econometrics techniques, to do impact evaluation here. Here we're combining remote sensing and econometric approach, and we also wanted to look at the impact at here. So that's what I'm going to say. I will keep all these detail about the heterogeneous the decision choices that farmer face when it comes to farming. I'm going to go straight to when the farmer decided to grow, for example, and then he has several situations. The land where he wants to grow rice could be located in a flood-prone environment, right? And if this is the case, looking at the green one here, is the light on? Oh, okay. If his land happens to be in an area which is not prone to flood, so we assume that he's going to get a normal yield. It's going to be like a business as usual. But if he happens to be located in a land that in an area that is prone to flood, and he adopts the STRV and flood happen, then he will get a resilient yield. But if he does not adopt, his yield will be affected, and that has implication on welfare and many other things, food security and so on. So this is just the conceptual framework that we have behind in conducting this study. So we've been very fortunate. There were previous surveys conducted before we proposed this study to SPIA. The first survey was conducted in 2014 with 1,500, a sample of 1,500 households. And then in 2017, those households were revisited again. And when we proposed the study to SPIA in 2022, we went back again and resurveyed the 1,500 households. So we collected data at the household level to get all the characteristics of the farmers, but we also collected flood data and data at the plot level. So when we, in the first two rounds, because of budget issues, we couldn't get the GPS coordinate at the plot level. We only collected the GPS at the household level. But in 2022, we got more funding and we were able to, get the GPS coordinate at least for 4 plots for every farmers. So you know that, you're lucky when you have a situation where the farmer's plot is located right to his household where he lives, right? In this case, when you make the plot see that, okay, it might be very similar, it's okay. But in many other cases, the plot, the GPS, the plot could be farther away. So when you assume that the GPS at the household level can be somehow be used as a proxy, yes, probably making some mistakes. So we carefully look into all those. One of the main things that the GPS, the remote sensing expert did as part of this team was to help us to get the flood data. I'm not a remote sensing expert. I won't be able to tell you much about all the work that they've done in order to get the flood information. But what I can tell you here is the flood information came from the global food database algorithm on the mixed CNN, convolutional neural long-term memory network. For those of you who are GIS or remote sensing experts, I'm sure you know what I'm talking about here. So the main idea here is see how the adoption of storage to rain STRV, predict determine yield that we have here. But we consider different measure of yield. So we wanted to make sure that what we are trying to evaluate is robust throughout different measurement of yield. So we consider here the first one, we consider the maximum flooding, which is the maximum inundation observed during the monsoon period. We also just look at the second one, which is just a mean, the average inundation that the plot has received. We also consider the third one here, which is the area under the curve. So basically what we did is we just took the integration of the area over time, and then this is multiplied by the time span of the satellite image, which is the one here. I can talk to you more about that at the end. And then another way to look at the flood data is to see how what is happening at the neighboring in flood also affect the decision to adopt STRV, and then how that has implication on yield as well. So all these different measures of flood will be considered in our estimation. So the household panel data is a very strongly balanced panel, 2,874 observation, and it has information on the household level characteristics. But for the plot, it's not balanced. It is a very unbalanced data set because I mentioned earlier that at the beginning, we didn't plan to collect information on the GPS of the plot. And also, so it has changed over time, as you can see here. So the plot information gathered many other characteristics which we use in our estimation as well. So I'm going to be showing you some graph here. Many of you know that today when you're doing impact evaluation, it is customary, especially for those who are doing RCT, it is customary to do a PAP, pre-analysis plan. It has many advantages. So we did the same here. Our pre-analysis plan is available online on. So basically, it allows you to avoid, data mining and also avoid. Very, very common thing. When you look at the adoption over time here, the blue bars here is the household level data adoption, and the orange one, the plot level adoption of the STRV. You can see that it has been growing over time for the 3 period. Also, when you look at the distribution of yield for each one of those here, the data that we have throughout all these surveys show the on average has a higher yield than the non-STRV. Them depending on the intensity of the plot. Like for example, here we look at the lowest bottom 25%, the medium, and the is observed for all the issues that we have so far. So this is just, a descriptive statistic of the data that we collected. Also, when you look at the flood information for all these different measures of flood that we have, the flood that happened in 2022 is much higher on average compared to the other two. Same for this one as well. I'm going to move to the empirical model that we use here. Basically, we focus on yield first. Wanted to see how the adoption of yield and also in a situation of flood or not affect the yield here. So we consider we consider yield here in a logarithm form. Then we also include in our model the household level characteristic and the time variant characteristic. And here the adoption variable, which is the STRV, is included, and the flood variable in the interaction between the terms. So basically, when you look at the calculation, you do the calculation of the coefficient here, we'll be able to tell you, how yield is affected in the situation of flood or not, whether or not you have adopted varieties. But when you look at this model, the economists will argue that, there could be indigeneity related to the adoption variable here, right? So we first considered the two-way phase effect model, but then we also consider a two-way phase effect model, but with instrument to address the issue. So and then for this, for economy, when it comes to choosing those instruments, it's a difficult issue. We really want to really satisfied with all the econometric. We consider here that the adoption of SCRV depends on previous experience in terms of coding. Showing you what we got from this estimation to justify why we all this model. So I think too much time on those, and then I move straight to the result here. So this is a big table, and it has a lot of information. Do not want you to look at all of them. Just focus on the last one, which summarize basically what we wanted to look. What is the average, how different is the average mean for the adopters and non-adopters for restoration varieties. So when we use the first model here, we notice that it is highly significant for in all contexts for all the flood measures that we have considered. We found a significant differences between the average yield for adopters and the non-adopters of the soil and rice varieties. So, which is good. But let's see what happened when we consider different categories in terms of the intensity of the flood. So we look at the bottom level, the medium one, and the highest. And you can see that what we have observed with the historical data is kind of repeated here pretty much exactly. You can see that on average, the SCRV, is higher than the non-SCRV in most of the cases. And especially when you go to the highest, intensity in terms of the flooding. So it somehow represents a good predictor of the yield in this case. And it mimics what we have actually seen with the historical data. Now I'm going to be showing you same observation with all the flood variables. Now I wanted to happen when we consider the historical variable approach. That is completely insignificant. So for all the flood measures, we didn't see any difference between in terms of yield between the adopters and the non-adopters. So we raised several flags. Is it that the instrument that we used was not the right one? Is it that we have to investigate further measurement? So this is a study in progress, and many things we're still working on those. But one thing that is important to highlight as in terms of preliminary result that I can show is that for non-adopters, for those who did not adopt, for non-adopting farmers who experience, they experience yield loss when the flood happened. But the STRV adopters, they have a resilient yield. At least we are convinced about that. But one thing that we didn't get any evidence about is we didn't see any evidence of yield benefit or penalty when the flood that happened. in a situation of using and nothing happened, there is no evidence yet. So these are the two major results that I wanted to show here. The team is still working on this. I think this is the first time this is being presented because we're still wrapping up on the study. There are still several limitations. I mentioned earlier that we didn't get the GPS coordinate at the beginning at the plot level for all. And you know that the plot, they change over time. Some of them get sold, some of them, the farmer could buy new ones. It could be, so we need to keep track of many of those, which is not always. We also face several issues with attrition and insufficient price data and information. One of the things that we've been doing recently is to find out about dissemination effort in each one of the area to see how much of stress-terrain rice varieties has been actually disseminated in those areas. So I'm going to stop here. I hope, did I make it on time or I went too fast? Yeah, I prefer to stop here and receive questions from you. Yeah, thank you very much. Yeah. So I wanted to hear suggestion, comment from you so we can continue improving on this. Yeah.
Close the session and thank you very much for attending the session, and please feel free to interact with all the presenters and feel free to discuss any questions, any topic you have in your mind. Thank you.